list. Next, now let us go to part C. In part C, we have to answer any three. Each carries 3 marks. Each carries 3 marks. Okay, see the first question. In this, explain the hybridization of SF6. SF6 hybridization. What is the formula for hybridization? Half into V. V means valence. M means monovalent. Monovalent means which can make only single bonds like hydrogen halogens. And A means anion. C means cation. So valence plus monovalent, addition of anion and cation you have to remove. 1 by 2 into V. V is group number of sulfur. Group number of sulfur is 6. And monovalents like what? Halogens like phosphorus, fluorine. So how many are there? 6 atoms are there. So 6 plus 6, 12. 12 by 2, 6. Steric number is 6 and the hybridization is sp3d2 hybridization. So now sulfur atomic number 16. So electron configuration is written here: 1s2, 2s2, 2p6 and 3s2, 3p4. In the valence, how many electrons are there? 6 electrons are there. Now, so these are the orbital structures I have written and all in this ground state. Now going to the excited state. So the electrons are jumping from one place to one orbital to another orbital and all, or one orbital to another orbital. You see here paired electrons are there. Then here it is becoming all are unpaired electrons. All are unpaired electrons. And how many fluorine atoms are there? Here 6 atoms are there. Each fluorine having one valence electron, one unpaired electron is there. So unpaired, 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 unpaired. These all will become pair. These two will become pair. So will become pair. So as a structure, what is the structure we are following? OH, octahedral structure. And this is fluorine. This is fluorine. How fluorine atoms are arranged according to this. So sulfur, all these fluorine atoms are in one plane only, one plane. These two fluorine atoms are above and below, above and below. Okay, explain sp2 hybridization in ethylene. That means ethene. Write the molecule of ethene, C2H4, hydrogen, C double bond C, hydrogens are there. This carbon is undergoing sp2 hybridization. Now you can see. Now you can see how the hybridization is happening in C2H4 ethylene. Now one carbon is there, another carbon. These are the hybridized orbitals. These are the hybridized orbitals. This orbital S is coming from the hydrogen. How many hydrogens are there? There are 4 hydrogen atoms. Now this bond is sigma bond. This bond is sigma bond, and this also sigma bond. Sigma, sigma, sigma. And here pure orbitals are there. These pure orbitals will join together. It will give you pi bond. By the way, and all like this, the formation takes place. Next, explain the types of hydrogen bonding. Hydrogen bonding having 2 types. It is of 2 types: intermolecular hydrogen bond and intramolecular hydrogen. Intra means within the molecule. Example: orthonitrophenol. Orthonitrophenol. L is missing here. Phenol. The structure of orthonitrophenol is this one. So where is the bond formation here? You see there is a bond formation between hydrogen and oxygen. This area, shaded area, is called hydrogen bonding. H bond. The shaded area is H bond. This is H bond. Hydrogen bond. H bond. Next, intermolecular. Inter means between the molecules. This is one molecule and this one is another molecule. This is also another molecule. That means between these molecules there is a bond formation. That's why it is called intermolecular hydrogen bonding. The shaded area is called hydrogen bond here. And one more thing you remember here, this is hydrogen bond. and this one is covalent bond. Previous KSET and JEE question. They have given this is A and this is B. So what is A? A is hydrogen bond. What is B? B is covalent bond. Simple question. Okay. Let us see the 34th question. Define electron affinity and how it changes in the period and group. In the period and group. So right, what is electron affinity? Amount of energy released when an atom gained one electron in its gaseous state. So suppose fluorine is there, it is gaining only one electron. It gets minus charge, fluorine negative charge, and means it is becoming anion. At that time, some amount of energy is released. That's why these are called exothermic reactions. The reactions in which energy is released is called exothermic reactions. Then electron affinity, how it is changing in periods and groups and all. In the period, how it is changing, it increases. In the group, it decreases. Group means top to bottom. Period means left to right, like this, left to right. Okay, next. Write a short note on diagonal relationship. What is diagonal? Generally, in a rectangular square, this is diagonal. That is the diagonal, like that here. Second period elements chemical properties are similar to third period elements chemical properties. That means second and third period elements, having few of them, not all, having similar type of chemical properties. This relationship is called a diagonal relationship. You can see lithium is diagonally related with magnesium, beryllium is diagonally related with aluminum, boron is diagonally related with silicon. This diagonal relationship is due to similar in their ionic size, not atomic size. It is ionic size and charge density. Very, very important. So many times they asked this question in previous KSET, KCET, and NEET also they are asking these questions. In NEET also they are asking these questions. Okay, lithium diagonally related with magnesium, lithium, magnesium, beryllium, aluminium, boron, silicon. Okay, like that. Just you remember a simple way like that, simple technique. Okay, next. Electronic configurations of copper and, you see, copper and chromium. Copper atomic number is 24. Electronic configuration is written here, and very, very important here because of stability here. Half filled orbitals are more stable. That's why the electronic configuration is like this. Next, copper atomic number 29. So the valence electron configuration you see 1s2, 2s2, 2p6, 3s2, 3p6, and 3d10 and 4s1. 4s1 because half filled orbitals are more stable. Okay, next. Answer in three, right? Each carries how many marks? 3 marks. Let us prove that pH plus pOH equals to 14. pH, right? You know very well that